last time. We want to solve this question. So the question says we should determine the total head and elevation head and the pressure head at a point A, B, C. So we want the total head at each point, right? So let's take point A. So point A, to calculate everything that is necessary for point A. So the first thing that we are looking for is the total head, right? So assuming this are D2, let me change the color. So this are D2. Assuming this are D2. So point A, if we want the total head at point A, is simply equal to the pressure head at A plus the elevation head at what A. Let me change this to HA. That is the total head. Now at point A, the pressure head there is 0, right? But the elevation head is what? 5 plus what? 3. And that's what? So the elevation head at A is 5 plus 3, and that gives us what? 8 meters. And so the total head at point A is what? 0 plus 8. And so the total head is what? 8 meters. So we found everything, right? Total head, elevation, and the pressure head. Then we go to point. Now, I'll give you a trick. Anytime they give you such question, right? The easiest part to find is at the top, at the base, and at this side. If we are asked to find parameters at a point within the soil, you can't go ahead, you can't find them first. So you have to find these points first. These points that are not within the soil. So it's either you have to find the points at the boundary because this is the soil, this whole portion is the soil. You need to find the parameters at the boundary of the soil before you can find the parameters within the soil. So very important. So these are the parts that we are going to find. So first of all, we start with A, then we come to B, then we come to B before we come to C. So let's take point B, right? Point B. So the total head at point B is equal to the pressure head at point B plus the elevation head at point B. So what is the pressure head at point B? The column of fluid above it, and that is what 3 meters, right? This is the column of fluid above point B. The column of fluid, here it is. Column of fluid above point B. And so that is what 3 meters. So the pressure head is like the column of fluid above a certain point. So if it is a piezometer that will be there, it's going to rise to a height of 3. Do you get it? Then the elevation head at point B. So the elevation head from the T to point B, that is what 5, right? And so the total head is going to be what 3 plus 5. And so the total head is equal to what 8 meters. Now you realize that the total head at point A and the total head at point B are the same because when the water was moving, right, and it came to this point, from as the water moved from B to A, there is no obstruction. So the head that the water will gain here is the same head that we will use to rise. Now here I forgot to say the direction of flow is going to be from this side. Direction of flow is going to be from this side up like this. So this is going to be the direction of flow. Very important. I did not mention it before starting solving. So this is the direction of flow. Remember I said water will flow from a higher head to lower head. So this is the higher head. So the water will flow in this direction. So as the water passes from D to B, there's going to be head loss. But when it gets to B, the head that it will get there with will be the same head that it will continue because from B to what A, there is no obstruction. But from D to B, there's going to be obstruction. We will see it as we go ahead, right? We see it as we continue with the solving. So that's the total head, right? Now the second question is to find um the total head at. So let's take point. So this is solving for I. So let's take point D. Point D. Now solving for I simply means that we are going to take the first case where the head loss is 1. So they are saying that this is equal to what? 1 meters, right? So at point D, the total head is equal to, I'm sorry, this is D. At point D, the total head is equal to the pressure head at D plus the elevation head at what? At D, right? Now, in this case, D is on the D2, so the elevation head at D is 0. The pressure head at D. So we can trace it here. So this is the pressure head at D. This is the pressure head at D. Because this D is the same D here, right? We don't use this one, no. We use this side. So that is the pressure head at D. So it is 5 plus 3 plus 1. So the pressure head at D is going to be 5 plus 3 plus 1, and that is equal to 9 what? Meters. So the total head is equal to 9 meters, right? Very beautiful. Now let's come back to find a point within the soil, just as I said. So before we can do the calculation for points, what we can do calculation, so let's see, point, point what? Point C, right? Point C. Now remember the direction of flow. This is the direction of flow, right? This is the direction of flow. So when the water was here, the energy that it had was what? 9 meters. When it came here, the energy that it had was what? 8 meters. Means that between here and here, there is a head loss of what? Of 1, right? Now from here to here, it remained at 8 meters. That is the head. So within, as the water moved through the soil, there was head loss. You know why there was head loss as the water moved through the soil. But we want to know the head at this point. So first of all, we can find our hydraulic gradient. That is the change in head over the length of the soil. So the change in head was 1, the length of the soil is what? 5, and that will give us 0.02. So every 1 meter, we have a head loss of what? 0.2. Now, from here to here is 5, right? From here to here is 5. But from here, from B to C is 2 meters, meaning that from D to C is what? 3 meters. So we want to know the head loss when the water moves 3 meters. So we want the new head loss 3 meters. The direction is very important. Not the direction is not from B to C, it's from B to C. That's why you are using the 3 meters distance. B to C. That's why if the direction was to be from B to C, then you use the 2 meters, but the direction is from B to C. So the head loss at 3 meters, that's C, is equal to the hydraulic gradient times the length there. The length there, that is the 3 meters length. And so the head loss at C will be equal to 0.2 times 3, and that's 0.16, right? So the head loss at C, that is the head loss between D and C, and so 0.6 meters. Now, head loss, we know head loss is equal to total head at D minus total head at C. And so by knowing this, we can see that 0.6 equal to, we know the total head at D, which is 9 minus, we are looking for the total head at C. So the total head at C is going to be 9 minus or 0.16, right? Now let me continue here. So I can see that the total head at C is equal to 9 minus 0.6, that's 7.4. 9 minus 0.6. It's 8.4, sorry. So we're going to get 8.4 meters. Now, getting this, we know that HC is equal to pressure head at C plus elevation head at C, right? Now, total head is 8.4. Pressure head, we don't know. But the elevation here, we know from the D2 to C, which is what? 3, right? So 3. So the pressure head at C will be equal to 8.4 minus 3. So I can say that pressure head at C is equal to Impacting all other races.